Welcome everybody to the second in our seminar series. We've got a really great lineup for you today. Before we begin, I wanted to just take a quick minute here and acknowledge our major sponsors who have been a fantastic support group for the A3, especially this year. We owe them a great debt of gratitude for sticking with us through this period of uncertainty. CIL Explosives, Onyx Maps, PEEPS, MND Safety that used to be TAS, Backcountry Access, VSEN Avalanche Control, and Arc'teryx. We couldn't do what we do without these guys, and we thank them greatly. So with that, I am going to ask Eric Peitsch, the Vice President of the American Avalanche Association, to take over as MC and introduce this evening's speakers. Thank you, Eric.
Thanks, Dan. And thanks to all of you for attending this Thursday evening. We actually was back in the spring in March when we decided that it would be a good idea to try and create something that we could bring our community together, our professional community together during the pandemic when we all couldn't be together in person. And there have certainly been many great workshops, virtual, VSSW, but it's kind of nice to bring everyone together a little more frequently. So thanks to all of you for attending. And it looks like we have over 200 participants tonight. So that's just excellent. Thank you. So let's get started. Our first speaker tonight is Pascal Haegeli. And Pascal is a professor at Simon Fraser University, where he holds the NSERC Industrial Research Chair in Avalanche Risk Management. His research interests are at the interface between the natural and social sciences, and his favorite projects are close collaborations with industry partners. He currently supervises a team of 10 graduate students working on a variety of avalanche safety topics, ranging from snowpack modeling to terrain analysis, as well as risk communication and education challenges. So I believe this is Pascal's 923rd presentation this fall. So we are very appreciative to have him share his expertise and research with us tonight. Pascal's talk tonight is titled Avalanche Airbags, What We Know from Research. So take it away, Pascal.
Thanks, Eric. Yeah, it's been a few presentations, but it's great to be here and to spend a little bit of time to talk to everybody here about airbags. Now, Dan, I think you still need to give me permission to share my screen. Then I can share my slides and get the show on the road. I think either Dan or
I think I got you there, Pascal. Sorry, I think you should be able to share now.
Yeah, so now it should be good. Just give me a moment to get this set up. And we should be good to go. All right, so I'll take about 15 to 20 minutes to talk about airbags. And I'm going to specifically talk about two research projects that I've been involved in. One was we tried to look at how effective is the technology at preventing fatalities based on accident data. And then in a second, more recent study, we try to look at how airbags potentially affect people's behavior. So whether that additional safety benefit they get from airbags potentially makes them choose more riskier terrain that potentially has the effect of nullifying the positive impact that airbags would actually have. So I'm going to talk about those two projects. Now, before we get started on this, just want to make sure everybody is on the same page here. Probably everybody knows that what these airbags are. They're basically sort of backpacks that have inflatable balloons in them. And if somebody is caught in an avalanche, they manually trigger those balloons and they get more or less instantly inflated and make you a larger particle. And this works, or this has a positive effect in an avalanche, because avalanches are what's so-called granular flows that consists of larger and smaller particles, as you can see on the slide here. And excuse me. And when avalanches flow down, they naturally, larger particles are naturally sorted towards the top. And that's a process that's called either granular convection or inverse segregation. And that's just what happens within these types of flow. Now, a victim in an avalanche is naturally a large particle. And the purpose of these avalanche airbags is to make that particle, that victim particle, even larger, which then further increases the chance that you get sorted to the top. And so it's important to know that avalanche airbags are not a flotation device. They simply create a large particle to take advantage of this sorting effect. Now, if you're an avalanche course instructor, it's actually quite easy to demonstrate that effect, and you can simply use an Nalgene bottle. You can put some rice in there, and you can put a bunch of marbles in there. And if you gently sort of shake that Nalgene bottle, you will see that the marbles eventually come up to the surface, even though their density is actually a lot higher than that of the rice around them. So you can nicely demonstrate that effect. And you can also clearly demonstrate that not all of the marbles are going to come up all the time. So you can sort of nicely highlight that it simply increases the likelihood that you get sorted to the top. Okay, so let's get to the first study where we try to get some insight about how effective avalanche airbags are based on accident records. And the real challenge with these types of studies is that you need to have a large enough data set. And so that's why I approached a whole number of avalanche safety experts from different countries to make this a collaborative effort. And so I was really lucky to get collaborators from the US, Canada, of course, then Switzerland, Austria, France, and we also had data from Norway and Slovakia. So we were really able to put a nice data set together for this analysis. Now, having a large enough data set is actually not the only challenge with this type of analysis. The second challenge is that the comparison between the control group, so victims without airbags, and the treatment group, so victims with airbags, that comparison needs to be fair. And those two data sets need to be somewhat comparable. And so the challenge is that for the control groups or for victims without airbags, we have all the fatalities are well documented. But unfortunately, a lot of accidents that have better outcomes, so where nobody passed away, are unfortunately never reported. So we have a very high rate of non-reporting for those accidents. On the other side, for the treatment group, where when avalanche airbags were introduced, there was a lot of reporting of successful deployments, simply because the community was really curious about whether this thing works. And manufacturers were also actively sort of sharing these successful deployments because they were keen to demonstrate the effectiveness. And so that resulted in two data sets that are just really not fair to compare. And so our challenge was to come up with a better approach to actually come up with a more meaningful comparison. And so what we did is that we first looked for any serious avalanche involvements where at least one person had an avalanche airbag. And we only included avalanches that were at least of size 2 to make sure we were actually dealing with an involvement that had the potential to kill. And then out of that data set, to make sure we have a fair comparison to the control group, we only picked out accidents that involved both users and non-users of Avalanche airbags. So that's the box in the bottom left that you see on this slide. And so these were basically both users and non-user involved in the same accident, and that sort of guaranteed that that comparison would actually be fair. Now, of course, airbag is not the only thing that affects survival in an avalanche. Like avalanche size, for example, is another very dominant factor. And so we used a number of regression analyses to actually isolate the effect of the airbag. And the technical details don't really matter all that much, but I want to present here is the pure effect that airbags had based on our regression analysis. And I'm going to show it here with these graphics that basically highlight the mortality. So how many people died out of 100 people that would be involved in these size 2 or larger avalanches. So for the control group, the people who would not wear an airbag, the mortality was 22%. So 22 out of 100 people died in those accidents. For people with inflated airbags, the mortality was 11%. So 11 out of 100 people passed away there. And so that means that we basically had a reduction in our mortality of 11 percentage points. Or in other words, we cut mortality in half, which is actually a very substantial effect. Now, unfortunately, this is not quite the entire story, because at this point, we've only looked at inflated avalanche airbags. And our analysis of all the accidents that had airbags included found out that in about 20% of those involvements, the airbag did actually not inflate, or there was a non-inflation involved. And when we looked at these 61 cases in more detail, we found out that about 12% were the airbags were simply destroyed because they were strained through some trees or had some very serious trauma to it. There was, in 17%, it was a device failure where there were some design issues, which primarily occurred at the very beginning of our data set. And then in 11%, we had a maintenance error where people didn't screw the cartridge back in properly. But then the largest part was actually the 60% where people didn't deploy the airbag when they were involved. So the airbag would actually have functioned properly, but for some reason at that critical moment, the user didn't deploy the airbag. And so that's really a significant impact on how effective the technology actually could be. And so one point here that's probably quite relevant for this audience is that we also found there that avalanche professionals actually had a much lower non-deployment rate when we looked at this in detail, which indicates that training or a better familiarity with the tool and how it's supposed to be used makes a big difference. But if we take this non-employment into account, then the mortality with airbag users in general goes up to 13%. That is still a 9 percentage point reduction, which is still a very substantial improvement. Now, unfortunately, there is limitations, and there's, as you saw in the bottom of this graphic, fatalities still occur. And I just want to highlight a few fatality scenarios that we know from case study to highlight where some of these challenges might lie. And so this is a shot of a fatal accident in British Columbia from a party of snowmobilers where somebody just took an avalanche airbag and did not have any of the traditional avalanche safety gear. And the person unfortunately still got buried, and he was somewhat unwitnessed. And by the time the rest of the party arrived, the person had already passed away, and it took quite a while for that individual to actually be found because they didn't have the proper avalanche safety gear. So avalanche airbags are definitely not a replacement for the traditional safety gear. This is an accident from Norway, quite a large avalanche with 6 people involved and 5 fatalities in total. And the challenge here was that the person with the avalanche airbag was already quite low on the slope when the avalanche released. And so that person was basically hit by the avalanche from above and then buried in that terrain trap at the bottom. So for the avalanche airbag to really work, you have to be involved in that flow of the avalanche so that you have time to actually get sorted to the top. And avalanche and terrain traps are still a bad situation. So even with the airbag. The last case study that I want to highlight here is a fatal accident in 2013 in Revelstoke, where somebody, while skinning up, didn't have the airbag properly tied. So they didn't use the leg loop to really attach it to their body. And when they were hit by the avalanche, they deployed the airbag, but it actually rode up in the avalanche and left them behind. And so they were still fully buried while the avalanche airbag was on the surface, and they didn't make it out of that avalanche. So again, sort of a strong reminder that if you use an airbag, you need to use it properly, and there's really no shortcuts here. Another potential limitation that has been discussed in the community quite a bit is that the potential of risk compensation. So that people, because they know they have an avalanche airbag, that they might actually enter more challenging terrain that they would otherwise, and therefore sort of nullify the effect of the airbag. And this was really sort of the impetus for our second study, which tried to look at this in more detail. There was a number of studies that tried to look at this before, primarily by comparing the characteristics of users of airbags versus non-users. But that's not quite the right comparison too, because with that comparison, you primarily compare people who buy airbags versus people who don't, but it doesn't actually necessarily give you insight into whether adding an airbag to your personal practices will personally make you a more aggressive skier or snowmobile rider. So again, here, the big challenge is to find a meaningful data set or a meaningful research approach to examine the effect of airbags on personal risk taking. Unfortunately, we can't do direct experiments. The university would definitely not let me do that, sort of have people ski avalanche terrain with or without airbags and see what happens. So we need to sort of come up with indirect ways to look at this. And so we sort of used 3 different approaches in this study. The first was an online survey where we put people into hypothetical but realistic decision scenarios. And it was a survey that we've promoted with the Swiss and Austrian alpine clubs a few years back. And we had about almost 400 participants in there, and there was a fairly even split between airbag owners and non-owners. And so we put them into these situations, and then in total 8 times. And every time they will get a different type of a scenario. And in the middle of that experiment, we either gave them an airbag or we took their airbag away. And then we compared their propensity or their preference for terrain before and after. And what we found out was that when you take the airbag away from airbag users, they tend to sort of choose less aggressive terrain. And there was some indication that for people who don't normally use an airbag and we give one to them, that they might choose slightly more aggressive terrain. So that was kind of a very indirect way of trying to figure out whether this airbag might have an influence on people's behavior. But there's clear caveats here because like these online decision scenarios are nowhere close to what real sort of decision scenarios actually look like. But we had some indication that airbags would actually lead to risk compensation. In the survey, we also asked people about their past avalanche involvements, and we asked them how much experience they have in the backcountry and when they purchased their airbag and whether their involvement was before or after the purchase. And so with this, we were actually able to calculate involvement rates for both prior to purchase and after purchase. And so what you see on the slide right here is the number of involvements and the number of years of experience in total for all of the 160 people that were included in our survey who had purchased an airbag at one point in their time, in their career. And so we can calculate these involvement rates. And you see that there is actually the involvement rate was higher after purchase. But based on this Poisson test, which can tell us whether that difference is actually statistically significant, it is not really, because you will be looking for a value there that should be below 0.05. And so with 0.1, it's basically, we can't say that there's really a difference between those. But in our survey, we actually classified people according, or we had a number of questions in our survey, which try to better understand people's motivations for going into the backcountry. And we were able to classify our sample into 3 different subgroups based on those motivations. And so we had some thrill seekers that were primarily out there to push the envelope and to sort of ski challenging lines. We have people that were primarily interested in powder. And then we have sort of the more conservative group that was primarily interested in being out in the backcountry without any sort of athletic objectives. And what we could find is that among the thrill seekers, we find a significant increase in the avalanche involvement rate after their purchase. And that sort of highlights to me that depending on your motivations, there could be a subgroup within our community where this risk compensation might actually come in quite heavily. So I think it's something important to be aware of. So that basically makes 2 out of 3 aspects where where we have a check mark for the potential for risk compensation. And then the last one is kind of more of a theoretical perspective that I found in this paper by James Hedlund, who sort of looked at, well, what are the characteristics of the situations and the safety device that might make a risk compensation more likely? And he came up with 4 different characteristics. The one is that the avalanche or the safety device need to be clearly visible. So people need to be aware that there is actually the safety device. And that's a clear check for an avalanche airbag. You definitely know that it's there. It's quite different from the avalanche transceiver that you can easily forget, but you're clearly aware of the airbag. The safety device might have the potential to negatively affect your experience. And here we also have a check with the airbag because they're heavier. You need to fiddle with them to put the leg loop on. So you're aware that this device is around, and it doesn't necessarily all the time make your experience more enjoyable. The third one is that the effect of the safety device, if that lines up with your motivation for going out. And that's where that analysis from before basically highlights this aspect, is that if people are really interested in skiing challenging terrain, then they might be skiing more challenging terrain if they have this additional safety device. On the other side, if you're just interested in troopsing around in the backcountry, then adding the safety device might not have an effect. And the last one is that you need to be in a situation where you can actually change your behavior. And I think that's potentially where there might be a difference between private recreationalists that have full control over how they behave versus in a professional environment where there might be other guidelines and operating procedures that might actually stop you from changing your behavior. And in those cases, an airbag might simply add an additional layer of safety. So again, airbags basically sort of have a check mark on all of these four characteristics, and therefore that theoretical perspective also sort of highlights that risk compensation is quite likely when we add airbag to our toolbox. Now, of course, then the obvious next question is like, well, is that a good argument against their use? And my personal opinion here is that it's not, because I think in the end, all of the avalanche safety efforts that we do as a community are really about enabling people to go into the backcountry safely. And so I think the airbag is simply another aspect of that enables people to go places where they might otherwise not feel comfortable to go. So I think it's all kind of along the same lines, and I think it would be unfair to sort of put that risk compensation lens only onto the avalanche airbag. But it's important that we go into this with some level of awareness of that might actually be happening. So to wrap this up, I just want to sort of highlight some key take-home messages that I take away from this research, is that airbags are an effective additional avalanche safety device. So they don't replace the other safety devices that we have, but they really, like, the reduction in mortality is substantial, but we need to know when that actually works and when it doesn't. And that leads me to the second point, that avalanche airbags are no silver bullet. There is still the chance to have mortalities with avalanche airbags. And so I think it's important for us to really clearly communicate to recreationalists or clients what are the situations where these devices work and what are situations where they might not work. So you can't fully rely on them. Again, non-deployments are one of the biggest limitations that reduce the effectiveness of the technology that it could potentially have. And so I think here it's really important to highlight that practicing is critical, so that you, in that critical moment where you need the performance of this device, that you can properly. And then the last point, risk compensation is likely, at least for some of the user groups. And I think here, avalanche course providers, we should bring that topic up so that people can be aware of that potential and then can make sort of informed choices about what they want to do with it. I hope you enjoyed this little whirlwind tour. If you're interested in sort of reading up on the glory details of these studies, they have been published both in academic journals as well as community journals. So about the Avalanche accident analysis was actually published in 2014 in the Avalanche Review. So you can read up on it there. And then if you're interested in the risk compensation study, you can find it at this URL on our website, and it's an open access journal article, so everybody can actually have access to it and can read it. Yeah, that's it from my side. Thanks for listening. If you're interested in our research of my group in general, you can find us on the web at avalancheresearch.ca. And you can always email me at the email address here on the screen, pascal_haegeli@sfu.ca, and I'm happy to answer your questions. So if there's any questions right now, I'm happy to answer them if we still have some time left.
That was great. Thank you so much, Pascal. We do have a few questions that came in during the talk. So let's see, the first one here is from Michael, and he asks, how does mortality reduction with an airbag compare to mortality reduction with an Avalon, if you know?
Yes, that's a question that has come up in the past, and I cannot answer that question, actually. Like, as far as I'm aware, the studies that have been done with Avalanche have always been very controlled. So basically people buried in the snow and then sort of medical monitoring of their vitals. I'm not aware of any study that would have looked at their effectiveness in actual avalanche involvements. Again, there it's the challenge is size of data sets, really.
Sure. Sort of on that note, though, how does risk compensation with airbags compare to risk compensation using helmets while skiing or snowboarding? I know you put a little bit of that in the paper, so I was curious what your thoughts were there.
Yeah, yeah, there's quite a few studies out there about risk compensation with helmets in ski areas. And actually for cycling as well. And from the top of my head, what I remember about the study in ski areas is that people who occasionally wear a helmet, there the risk compensation effect was the highest. And then people who regularly use helmets, their behavior sort of comes back down again. So it's basically sort of at the very beginning, once you start to use that new safety device, you're really trying to get the maximum benefit out of it. And then later it normalizes again. And I actually have my partner, she, like the first day she wore a helmet within a ski area, she popped out of her bindings like multiple times. So I had it like live up front there for me.
Great. We have a question from Caleb, and the question is, did you look at complete burials versus trauma fatalities? And he's curious if the mortality rate was higher for trauma, for example, being pushed into trees or off a cliff with an airbag versus no airbag.
Yes, so we didn't eliminate trauma fatalities out of our data set. And so of course, like airbags wouldn't make a difference in trauma fatalities. So that's kind of integrated in our analysis there. With all the caveats that in the end we had quite a small data set, and so it's probably not fully representative, but it's definitely like in Canada, trauma fatalities are up at 25%. So it's really just targeting that 75%.
And it looks like we might have a live question. Let's see, Frank has a question. Dan, can you unmute Frank?
Frank, you're unmuted. You'll need to turn, or you have an ability to unmute. There you go.
Yep, got it. Pascal, thanks. Wondered if you had gathered enough statistics to know whether the, proposed advantage of an airbag pack deflating and providing an air pocket is a real thing, or is that at this point speculation on the part of manufacturers?
Yeah, I don't. But just from the top of my head, I'm not quite sure whether some European groups sort of started to look into that. And so I would have to dig that up, but I sort of feel like there was some research going on along those lines, but I can't from the top of my head give you sort of the results that they had. So if you want to send me an email, then I might be able to dig that up for you.
Okay, thanks. Would that be like Brugger and those guys looking into that?
I don't remember.
Okay, thanks.
We'll take just a couple more questions here. Let's see, we've got one from Robert that says, have manufacturers tried to address non-deployment issues with videos or additional training that you know of?
Well, I think key is really practice. And so I think manufacturers are really sort of encouraging practice. And so, yeah, I don't know whether there's any other sort of abilities to really address that, but I think it's a really important point to sort of highlight it in courses or so, or in manuals too, that this practice is really a key. There's some advantages to the battery powered devices, but you can definitely still practice with the canister ones as well. So it's just key that people actually do it, similar to practicing with beacons.
Great, thanks. And there's a comment from Scott McIntosh, and they actually published a study on that topic in Resuscitation Journal.
That's right.
Yeah, not too long ago, as I recall. So maybe Scott, if you want to post the link to that, if you're able to, in the chat for everyone to see, that would be great.
Yeah, thanks, Scott, for reminding me of that. Now it all comes back. So glad you were here on the call.
We'll take one final question from Marcus, and he says, an Avalanche level 1 student once asked me, can a backcountry user wear a large backpack filled with pillows and have a similar effect to that of an airbag backpack? He wants to get an expert's response.
Well, yeah, it would probably work, but it would just be really uncomfortable for skiing. So yeah, I mean, sort of the legend says that the concept of the airbag was actually sort of discovered by a hunter who was carrying his chamois back from the hunt and sort of was involved in Avalanche and realized that it sort of carried him up. So yeah, as long as you're a large particle, this is supposedly works, but I think airbags are the more comfortable solution for this.
Indeed. Well, I guess we'll finish off with that one, but thanks, Pascal. We really appreciate it. And if anyone has any more questions, you can post them there in the Q&A and we can try and answer them, or maybe Pascal can as well. But we need to move on to the next presentation. So thanks again, Pascal.
Yeah, thanks for having me, and safe winter to everybody.
Thank you, Pascal. Terrific.
All right. Our next speaker is Daniel Howlett, more affectionately known as Howie. And Howie recently finished up, I think it's about 700 years of ski patrolling at Alta, Utah. 30 of those years were spent as the assistant director of the Avalanche program for the Alta ski area. In 1996, Howie co-founded and co-created the Westwide Avalanche Network. It's known today as avalanche.org. And this turned into the web portal for the American Avalanche community. In 2010, he was awarded an honorary membership in the American Avalanche Association. He started Know-How Inc. in 1998 and continues to operate this consulting business that specializes in remote environmental monitoring systems. Working with the RECCO rescue system since the early 1980s, he has been instrumental in establishing the network of Avalanche professionals and SAR organizations that use RECCO in both North and South America. He currently works for RECCO as the Director of Training and Technical Support in North America. So we're very excited to have Howie with us tonight to share his vast amount of knowledge and some case studies using RECCO technology. Howie's talk tonight is titled An Overview and Update of the RECCO SAR Helicopter Detector. Howie, over to you.
Hello, Eric, and thank you for the great introduction. Well, good evening, everyone. Thank you so much for time out of your busy schedules to listen to this webinar. A big shout out to Dan and the whole crew that made this possible. I'm here to talk about RECCO tonight. Our new slogan is to be searchable, and that's because of the change in technology that RECCO is going through right now with the new helicopter detector. Most of you are probably professional rescue workers, so you're familiar with the equipment. This is a quick reminder about the two-part system. There's the detector, whether it's handheld or suspended from the helicopter, and the other one is the passive reflector. Basically, the detector transmits a signal out, and when it hits one of these reflectors, it requires no battery. You can never turn it off. It doubles the signal. And the detector is also a receiving unit. So it not only transmits, but it also receives. And the reflector you can just think about like a mirror in a dark room. And you're walking around the room with a flashlight. And as soon as you hit the mirror where the light comes back to your eyesight, that's the same principle that this is working on. You know, it's hard to believe I have 15 minutes to talk about almost 50 years of history. A long time ago, Magnus Gronhed in 1973 ended up losing a couple of friends in an avalanche in Åre, Sweden. That was the day he was actually in the rescue party, and he had nothing but his ski poles to probe in the snow. And from that point on, from the sorrow and frustration, he figured as an engineer, there's got to be a better way through technology to find people. Well, that started in 1973, and 10 years later, you can see the left frame of this slide. In 1983, that's the first RECCO detector that came out. And the research and hard work of all those years was rewarded about 3 years after that. And that was when the first live rescue took place in 1986 with the detector and reflector. Yeah, you go to the far right, and that's a detector now. It's like everything else. It's been able to get smaller because of technology and last longer and search better. Today, what we're going to do is go into the next technology advancement. RECCO has never quit looking for better ways to find people with the same reflector. A lot of times people go, well, what about my reflectors from the 1980s? It doesn't matter. That's one of the neatest things about this system. The detectors keep getting better and better, and we can search faster and we can search more places, all with the same reflectors that have been sold over the past 2 decades. Today, with the helicopter detector, we're going to fly through this video. It's a little clunky, but we're going to go over 3 items with reflectors in them, just to give you a sense of the speed. Now, we're not doing an active search. We're just flying through about a square kilometer of land, 250 acres. And our search corridor is so wide in this film, you don't know whether you're going over the top of it or if it's way to the right, way to the left. You just don't know. We're just trying to give you a sense of speed and height that you're flying at. These are high tension power lines, if you can see it in your film, and let you know just how high we are above the ground. The forest canopy that we just flew through is anywhere from 90 to 120 feet tall. So you can cover a lot of terrain in a hurry. That's why the new slogan is Be Searchable. We're still going to be a primary tool for avalanche rescue and winter rescue. But now, when we can search such huge areas, it's really worthwhile to have reflectors on year-round. Here's just an example of the type of signal that comes out from the bottom of the detector. It's a directional antenna going right towards the ground. And it's looking for this same reflectors that's in ski clothes that are now in some summer clothes already. You know, if you're talking about searching an avalanche, even a huge avalanche for many, many acres is really small compared to looking for a missing biker, a missing hunter, a missing hiker, just in a forest like you see in this slide. So you start out with a pretty large grid, a large search pattern, 300 feet above ground level, as I mentioned earlier, at 60 miles an hour. That means your search corridor is 300 feet wide in the forest, and basically 250 acres in about 6 minutes. To really put this into perspective, just think about it. 30 football fields a minute at 60 miles an hour, and you'll hear a signal like you do. It's kind of a neat thing. It's a one-to-one relationship with the height above ground level. Your AGL matches basically the radius that you're painting this search tone with. So right now, if you're 300 feet above ground level, it's a 300-foot diameter search. 200 feet is going to be a 200-foot radius, and so on as you go down. As you lose altitude and you're doing a fine search, it's just like the handheld detector where there's a remote control. The remote control is wirelessly communicating with the detector. People often wonder if you can deploy the detector if you have an aviation emergency. And yes, you can. If it's on the hoist, you'd use the hoist cutter. If it's on the cargo hook, you just let it go on the static line. There is no connection. The detector has its own battery source, and so does the remote control you see in this slide. You can see there's 8 different levels of power, and so it becomes a real need to practice as much as you can being a remote control operator and also communicating with the pilot and crew. This is going to be different in every single air support place that we've gone to, and I think we'll continue to go to, and everyone kind of pretty much develops their own pattern of use. You can think about all the grids that you do with all the other rescue devices, and it's really no different when you're up in the air. You know, you adjust your corridor widths according to your height above ground level. And because it's a helicopter, the helicopter does a fairly flat turn when it comes around if you're doing a grid like this. And you can see it's pretty easy to run out of places to search. Hopefully you'll find a person. But this is pretty incredible when you get to fly with this device and you go through your first find. It's pretty neat. So where is this happening? Well, if you can see the numbers inside the red circles over here in North America, the numbers represent the placement and training of a RECCO SAR helicopter detector in order of where they are in the world. You all know that RECCO is a global company, and we got to start here is numbered lucky 13 in Kalispell, Montana, with 2 Bear Air They have a hoist. They can deploy it on the hoist, and they also use the cargo hook. Most of the operations that we've placed and trained, they support many search and rescue groups. Some are statewide. Some even go out of the state that they're based in. And it's kind of too bad that we don't have enough time to go through what kind of search what the search mission is to help you decide whether you're going to use the hoist or use the long line. That's all figured out at the time that you're getting the call. There's 3 pilots at 2 Bear, the train, and when you initially get there with the detector, we give all these places as much time as they need to train with it and to work with their search and rescue communities, the people that they provide air support with that'll be on the ground. You know, being on the ground and being really good year-round with the handheld detector is going to be key for all of us to save lives. And that is if you don't have a verification, a visual verification doing a RECCO search in the summer or winter with the helicopter detector, the aircraft, the crew up there is going to drop a marker, and they're really going to depend on us on the ground to be able to search adequately. So when you first get it, you train and you figure out all your routines, and it is different with every single placement just because the aircraft's different and also the response time is different. So the second organization to get placed and have a helicopter detector was in Salt Lake City at the Utah Department of Public Safety Aero Bureau. This helicopter supports every search and rescue group in the state of Utah, as well as lending mutual aid to surrounding states. They have 3 pilots and do hoist deployments as well as use the long line, once again deciding what type to use on each mission. The aircraft is totally different at each operation, as I said earlier. Once again, if they're in the hangar, they spend a lot of time figuring out how to transport, what they're going to do, what's the operation, what are the steps of getting it deployed on the hoist, what are the steps of carrying it, what are the steps of using the cargo hook. So there's a lot of training that's done before the rotors even turn. The next stop was Snohomish, Washington. The helicopter rescue team there, they're flying a UH-1H, and there's 5 pilots that have trained here, and they have, like all the operations, an amazing amount of talented people. That's one of the neatest things I've been able to experience is all the search and rescue groups, as well as the flight crews, just really talented people that really care a lot about what they do, and they're all really good at what they do. So it's been real fun, and it's going to continue to be fun job to have. So here they are figuring out the routine, the rhythm, how's it going to get transported, how are you going to deploy it if you're using the hoist, and how are you going to work together. Just north of there, the next stop was the North Shore Rescue Group out of Vancouver, British Columbia. They have a very, very busy program, being so close, having a metropolitan area so close to the forest. And their air support is out of Vancouver, Talon Helicopters. And North Shore Rescue also does mutual aid for many search and rescue groups. They all work together, and same with Talon Helicopters. They support a lot of search and rescue folks in the immediate area. The next placement was over in Canmore, Alpine Helicopters. A lot of you are familiar with their operation, and they support the Banff National Park rescue crews and dozens of search and rescue groups in both Alberta and British Columbia. So it's a good place for a detector, and it's in Canmore there and can be dispatched whenever requested. That brings us to the last placement. This happened actually just in November, and Teton County Search and Rescue is where the detector is located. Trained a pilot there and a lot of crew members from Teton County SAR, as well as some rescue rangers from Teton National Park. Both organizations have air support from the same helicopter company, and it's located year-round now in Jackson Hole, Wyoming. Certainly a place where there's a need for a RECCO detector. Just to touch on how big this has gotten, in the handheld detector world, there's over 2,000 detectors in 800 and more ski areas and search and rescue organizations. Kind of estimated at the last count around 15,000 plus professionals have been trained in the use of the handheld detector. And although there's only 19 helicopter detectors out there, I think we're gonna see more and more helicopter detectors get placed all across the planet. And RECCO's vision is to have everyone be searchable to help save lives. And we not only want to save lives, but we want to also cut down on the time that rescues take and the exposure to all the rescue workers on these really long extended searches. The product brands are awesome. It's been amazing to me, being on the rescue side of things, to see the passion and the care that the 150 brands that put reflectors in their gear have about their customer safety. And now we're seeing it in bicycle helmets and backpacks, climbing harnesses, the lighter jackets, the lighter footwear and pant that are going to get worn in the summer and fall. We're even starting this month, we've been integrated into camouflage clothing at a place called Forlow, and they're doing camouflage hunting clothes with reflectors in it for hunters. So we just plan for it to take off, and trying to get it in everybody's mind that sure, it's a primary professional rescue tool for avalanche work, but right now, we want to let everybody know that it's to be searchable year-round. With the helicopter detector, it's going to really make a difference. So once again, I thank you for your time, and just want to say thank you for your support of RECCO. You folks out there with the handheld detectors, practice, 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 because we're going to be, I'm sure, getting calls year-round now to jump out in the wilderness and try to help find people. Be searchable. Everyone stay safe. Take care.
So the cool thing is that we have a bunch of great questions. So let me relay some of these to you. We have a question here. Let's see. This is a good one. Could a RECCO detector be adapted to very lightweight so it can be deployed by a drone?
Yeah, there's actually drone research going on in several places over in Europe, and they're looking at that technology and testing the technology. That development's underway.
Cool.
Yeah, it's great.
Seems like drones are used for everything.
Yeah, they really are.
So we've got another one here. What's the current depth range of handheld RECCO technology in avalanche searches?
The what range?
The depth range.
And in snow?
Yeah, so in avalanche debris, in avalanche searches, what's the current depth range of handheld?
Oh, okay. As far as the handheld goes, the range in any sort of snowpack, whether it's avalanche debris or not, is going to be totally affected by the water content in the snow. RECCO does not work in water, and it has very low range in water. Snowpack and avalanche debris, even in spring slides, wet snow avalanches, you're still gonna get pretty good range. I think it really depends. You can't really even give it a range too. It depends on the angle of the reflector and the angle of the detector when it finally gives a signal return back, but it is decreased as the snow gets wetter. In typical, in typical snow and avalanche debris, probably 60 feet, probably.
Okay.
Yeah. If not in 60 feet of depth, but could say 20, definitely.
Okay, cool. Another question is here. Do phones show as a reflector?
Well, we have phones and GPS units and cameras and all that. We call it incidental electronics. And, even if you have 3 phones lined up together, you're going to have different range from all of them, and some you'll have no range. So incidental electronics can and have given a return signal, but it's nothing you'd want to rely on. It's nothing like the reflector at all.
Sure. Looks like we have a live question here from Joe.
Joe, this is Dan. You should be able to turn on your mic now. In the lower left-hand corner of your screen, there's a mute button that you can turn off. It says you're unmuted, Joe. Go ahead.
Okay. I just wanted to mention that up here in Alaska, the South Central Alaska Avalanche Search and Rescue Association, we have several RECCO units here, and we've actually had training in using them with a helicopter. And we were actually lucky enough to have Manuel Gersich come up and give us some training in the use of the RECCO units here.
I'm sorry, Joe, you cut out there.
Oh, okay. Okay. No, I just wanted to mention that we've had training up here in Alaska in use of the RECCO units, and Manuel Gersich, who's done a lot of work with those units, actually gave us some training up here to use them in the helicopter for searching. So.
Oh, excellent.
Yeah.
Good.
Great, thanks, Joe. Next question, Howie, is does the RECCO have the ability to be quick released from the helicopter in case of emergency? Oh, looks like you're frozen again.
Yep.
There you are. All right, Howie, I'll repeat that question again. Does the RECCO have the ability to be quick released from the helicopter in case of emergency?
Yeah, I thought I might mention that the remote control is a wireless communication between that and the detector. And there's the detector itself is powered on its own. It has its own power source. So the only connection is either with the hoist rope, which does have to get, if there's an aviation emergency, it'll be the first thing to go.
Got it. Great. Let's see. Let's do one more question here. How does the system avoid potential false positives from searchers with the units on?
Well, it's kind of a thing that we go by even with the R9. And let's say if you have searchers out in the field that might have reflectors on, and they're visual targets, you can kind of eliminate any target.
Let's see if Howie comes.
Is it going off again?
Yeah, you cut out on us. So there's a bunch of questions in the Q&A, Howie. If you want to stick around, you could answer those and type those in. I think they should all be in there if that works for you. But because of time constraints, we do unfortunately need to move on to our third speaker. But I want to say thanks, Howie. We appreciate it. And that was an excellent talk. Thank you so much. All right. So we're moving on. There's Jonathan. He's our final speaker this evening. Jonathan is the A3 member affiliate representative and the only A3 Board of Trustees member on the East Coast. He's also an Avalanche safety instructor for both ARI and the National Ski Patrol. He published his first comparison of Avalanche beacons in the Avalanche Review for the 2006-07 season, went on to write beacon reviews for the Wild Snow blog, and has assisted for many years on the Beacon Reviews website. He's also published many articles for the Avalanche Review on avalanche beacons, airbag statistics, and avalanche fatalities. So Jonathan is an economist by training and profession and not an electrical engineer, despite admittedly having engineering tendencies. So he said he reserves the right to refuse to answer any excessively technical questions tonight that try to stump him on beacon technology. His talk is titled, "Why Aren't Avalanche Beacons Perfect?" Over to you, Jonathan.
Okay, now is my screen showing?
Yep, you're good to go.
Oh, okay, good. Phew. Okay, and my little picture is showing too. Okay, zillionth time presenting on Avalanche beacons, first time presenting about anything on Zoom, so hopefully this goes okay, maybe even perfectly. By contrast, why aren't Avalanche beacons perfect? That's a question I get asked either directly or indirectly a lot when I'm teaching Avalanche courses or just dealing with my own partners. So we're going to talk about some underlying reasons why they just can't work flawlessly. On the other hand, if you think that Avalanche beacons do work perfectly, well, I have some news for you. So disclaimers, besides the ones that Eric already listed, I'm not going to review individual beacon models here. That's not the point of this presentation. I'm not trying to address specific shortcomings of particular models, although I will refer to some discontinued models, especially from old-fashioned times. And any preferences I show for individual beacons, those are just my own personal preferences. They're not blanket recommendations. Ditto for whatever beacons I might display as part of my presentation. So one thing I hear a lot is, gee, my phone is some combination of nearly free, nearly perfect, and nearly magical in everything it can do. Why can't a beacon be like that? Well, first, obviously you have economies of scale. You know, your phone here, I mean, who knows how many of these are produced in the world each year? I'm an economist, so I should know, but I didn't do that research. Avalanche beacons, by contrast, are just a drop in the bucket compared to other consumer electronics. Also, the market for avalanche beacons is pretty fragmented in a good way. That means there's a lot of competition. On the other hand, that means that each manufacturer has a pretty small market. And it's kind of interesting the way that each major alpine nation has its own beacon company. There also used to be one in Italy a long time ago. And probably some people remember the beacon that was produced by a company in Canada. The best that can be said about that is Canada, besides that, is still a fine nation. And then there's also the matter of subscription revenue, whether it's for your phone or for your cute little satellite messenger device. These devices are subsidized by all the subscription revenue. By contrast, when you get a beacon, that's all you ever have to pay. And the market isn't just small, but it's kind of undifferentiated. It's almost like years ago when alpine touring bindings were kind of a pretty small deal. They were all kind of similar to one another. Some were a bit lighter, some were a bit heavier. They were all kind of clunky, but they didn't specialize to the extent that, you know, now you've got rondo race bindings. They're these teeny little things. And, you know, if people want to go clunky style, you still have plate bindings. And there's all sorts of stuff in between. Whereas beacons, each one is pretty much aiming towards the middle of the market. But the other issue is you might think, well, okay, fine, but why can't you just add an app to your phone that would make it work like a beacon? There have been some phone apps that purported to add avalanche searching capability, but they were deficient to the point of being borderline criminal. The reason is just transmitting on the beacon spec is not all that easy to do. And the reason I have this slide up here is one day a few years ago, I got a call from a friend of a friend of a friend who said he was an electrical engineering professor at the local university. And he had some students who, for their senior project, were going to do something involving avalanche beacon searching. And he was wondering if he could borrow some old beacons for me to use as targets. And I said, sure, of course, plenty happy to loan out. But you're an electrical engineering professor. can't you just go down to your local electron hut and cobble something together with several dollars worth of spare parts? And he said, well, it's not that easy. He approached a colleague of his who happens to specialize in antennas. And when he asked him, hey, how can I cobble together a transmitter rather easily on the Avalanche beacon spec? The guy just kind of sighed and shrugged and said, oh man, you just got to go buy yourself an Avalanche beacon. It's really hard to do that. And the reason it's so hard, I hope this doesn't date me too much, but there was an X-Files episode that was sort of about this. It wasn't about space aliens. It wasn't about a pandemic that devastates the world. Unfortunately, that's no longer science fiction. That's the reality we're living in. But rather, it sort of had an underlying basis to it in fact. And the reason is there's this complex in the Midwest that has ground antennas that are a total of 84 miles long that were used to communicate with US nuclear submarines out at sea. And because they're under so much water, you need to have a signal with a really long wavelength to penetrate that water and reach them. If you think 84 miles is long, there is actually a proposed system that would be 6,000 miles long and cover 2/5 of the entire state of Wisconsin, one of those crazy Cold War things. Now, of course, you're not buried under that much snow, but still you're buried under a lot of snow that you need a signal with a really long wavelength. Cramming that into your typical small Avalanche beacon housing is kind of complicated. So that's why you're never going to have a phone that can act as a real Avalanche beacon. The other problem is you're having to design a product that's going to be used in a panic situation and going to be used by basically everyone out there who's a ski tourer. And lowest common denominator, I'm trying not to be too condescending here, but hey, I'm told this can be an advanced presentation and we're all A3 members, a higher level of ski tourer, I suppose, or Avalanche professional. And you're wondering, what on earth does this have to do with Avalanche beacons? Well, years ago, I was tasked at the consulting firm I was working at to come up with the latest version of a rather primitive user interface for this one computer model that performs some financial economic calculations. So I got together with my software buddy, and he designed the user interface with my input, and I did the calculations behind the scenes. And we designed what we thought was the absolute best model. It was so easy to use. We did such a great job. I think I almost dislocated my arm patting myself on the back so frequently. And then I unveiled it at a training course, and wow, we had done such a bad job because the model we had designed was perfect for us. It wasn't necessarily perfect for everybody else. When you're designing an Avalanche beacon, you have to have it be usable, obviously, by the ordinary user out there and in a panic situation. So that's some background stuff, but getting to the core of the matter, the problem that all these beacons face is they're trying to add all this advanced searching technology onto a beacon transmission spec that was never intended for this purpose. Now, this might look a little complicated, but it's kind of simple. All it says is that there's a cycle that's 1 second long, plus or minus 0.3 seconds. And so for at least 7/100ths of a second, it has to go beep. And then it has to be quiet for at least 4/10 of a second. And this cycle has to be repeated somewhere between 7/10 of a second and 1.3 seconds. That's the only information that's being transmitted, is just that simple beep. By contrast, say a GPS device, that's sending out a signal from a GPS satellite that says, I am GPS satellite identifier number. My geosynchronous orbit is pegged to this spot, and the time is exactly down to whatever millisecond. So this creates a number of problems when a beacon is trying to find out all these things about a target. So how can a beacon sense direction? Well, it really can't. All it's doing, and this is something that was pioneered by BCA, so giving them credit definitely for being the first, is it's first saying, okay, if I look in this direction, how strong is that beep? How loud is that beep I'm getting? And now, if I look 90 degrees in that direction, how strong is the beep in that direction? Well, then it interpolates to somewhere in between. then how can the beacon sense, well, is it really there or is it back there? Once again, the answer is it really can't sense that. It's trying to look for all sorts of clues. So just like when the first digital beacons came out, and the only way you could tell if you were going in the right direction was the distance numbers were getting smaller instead of bigger. The beacon is using that as a clue, and other clues like an internal compass, accelerometers, and other things that are kind of trade secrets, and every now and then come to the fore. This is a lawsuit between two beacon companies from quite a few years ago. Had to do with one claiming that its idea of an internal compass to sense fore and aft was its idea, and the other couldn't use it. So how can the beacon sense distance? Well, you know where I'm going with this. It really can't. All it's saying is that, well, usually when I get a signal this strong, it corresponds to a beacon about that far away. Now, of course, that all depends on how the antennas are aligned with one another, so that's really imprecise. How can the beacon sense multiple signals? Well, you know, I copied that from before. It really can't. The analogy that's often used is you've got a bunch of race cars going around an oval track, and the beacon is looking for little clues to try to figure out which signals are coming from distinctly different beacons. So I said earlier, showing the beacon spec, that they have to make these laps every second, plus or minus 0.3 of a second. So some are going to have shorter cycle times than others. Some are going to have slightly longer on times. Some are going to have longer off times. In other words, periods of silence between those beeps. So it's looking for all those little clues that were never really designed to be used for this purpose, but by most part, by happenstance, it can use those clues. That also means that when you take an exam, when you have to find, say, 3 beacons within 6 minutes or something like that, for an AMGA guide exam or some like a level 2 pro exam. I'm probably mixing up my terminology now, it's been changed so much. If you get only one shot at it, it really is kind of unfair. Now, if you come to one of my schemo races and you don't do that well, it's your fault. On the other hand, if you flunk one of those multiple beacon search exams, it might not necessarily be your fault, because it could just happen through luck that a couple of these signals almost perfectly overlap, even as they're going around again and again. And it's much harder just by bad luck of the draw for you. So whenever you design an exam like that, you should definitely give people at least 3 tries. Another problem is that there are some beacons out there, I think it's really just this old orthodox F1 focus, and there's still a zillion of these around. And it had a rather clever design for its day to allow people to listen to it more carefully. This is when all beacons are analog. This is when it was originally designed. It would have the on time, but during the off time, it would have a little bit of a signal in the background just to tell it, yeah, I'm still here, I haven't gone away. Well, the problem is when you get a modern beacon that's trying to differentiate among different signals, it looks at this on time here from this one beacon and says, okay, that's one signal. Then it hears this little thing in the valleys and it says, oh yeah, that must be another beacon too. Well, it's not. That's why we call it ghosting. So with all these in mind, all these problems in mind, can beacons become perfect someday? I would say no, at least with the current beacon spec. And in addition to that, the problem is when you look at all the big breakthrough models of the past several years that we thought were going to be really, really different, they all kind of fizzled. There was one model that was going to have a GPS that would aid you somehow in your searches. I was really excited about that, you know, kind of like years ago when people were lining up outside stores for Windows 95 operating system, if you remember that. I would have been lining up in front of a store to be the first one to get that. It was delayed years and years and years, and then almost as soon as it came on the market, it was recalled. There was one beacon that I kind of liked. Instead of just showing the distance and directional indicators and a list of all the signals, it tried to show a map of all the different signals and the distances between them and the position to you, the searcher. It was kind of cool, but I'm not sure it really helped that much. And guess what? That model was also discontinued. More recently, we had a model that would use its third antenna in the kind of Z plane, if you want to call it that. Instead of just using it for the find search, it would use it right from the very start in the secondary search. It would flip out, it would have a much longer length to it, but that really didn't seem to make any difference. It was an okay model otherwise. And then after a few years, it was discontinued too. Then there was a lot of marketing hype about one manufacturer that would have a secondary frequency for additional data. It's actually two different frequencies, one if you're in Europe, one if you're in North America, and if you're in Asia, supposedly you're not allowed to use it at all. It's a great beacon. It's one of my favorites, both the original and the successor model. But does that secondary frequency really add much value? I certainly don't think so. Can beacons become better? Absolutely, especially because they are. Each time a new flagship model has been introduced for each of the brands in the last few years, it's definitely better than its predecessor. We can go through so many different improvements, and they've come such a long way also since some really antediluvian beacons we have here. Actually, I'll hit the stop share so you can see me and get a better view of some of these beacons. If you want to go really far back in time, here's an old Raymer beacon. If we were in person, I'd ask people to raise their hands if they ever had the Raymer ski touring binding. It comes with a super high-tech pouch harness, and then it gets stuck. It's not the right size. So once you eventually get it out of here, making progress, so my partner hasn't died yet. I'm actually not exaggerating. It's really hard to get this out. You can see the super high-tech battery case. You just stick a 9-volt battery in there, and then to make it transmit, you take your headphone jack and you stick it in one of these, and then to search, you stick it in the other. And then after you've given about maybe half an hour or so of that, yeah, maybe you try to use the Avalanche cords, then you go back into town and notify the next of kin. Ortovox F2 was the same way. The only way to search was to stick a headphone jack into here. But, you know, although beacons have come a long way and there's been a lot of great refinement in recent years, realistically, as far as I can tell, the pace of innovation is kind of slowing down. It reminds me a little bit of rondo responding, especially since pretty much everything does. This one here is almost 10 years old. This one is the latest and greatest. I think this one weighs about 1/10 of an ounce less, but unfortunately, you know, it's hard when something is this good, given the existing interface, to make it that much better. Same thing with beacons. When you're limited by that spec, I think there's a limit to how much better they're going to get. But still, it's good news. The average beacon out there, as old ones are getting retired, is a lot better than it used to be. And I do have a lot of confidence that Avalanche beacon searches are a lot better conducted these days. Would be best, of course, if we never had to conduct any searches. But if people are going to be buried, it's comforting to know that beacons perform a lot better than they used to. So thanks, and any questions now? Unless you're an electrical engineer, then you're not allowed.
Thanks, Jonathan. That was great. So a couple of questions here. So I guess if we can't really improve the given technology, what about any improvements with regard to interference with other digital objects that we're all carrying now? Could that be improved?
So there's one company that claims that it can. It definitely can. It will. So actually, let me back up and say there's a different one to illustrate here. So originally, and once again, just for demonstration purposes, not an endorsement. Originally, for multiple antenna beacons, only one antenna could be used to transmit. That was on the long axis. Now on the shorter axis, there are two companies that say they can switch antennas for transmitting. Not transmitting from both at the same time, then you definitely be ghosting. So one says that it has a gyroscope. So depending on how you're buried, it will change the antenna transmission so that you're not transmitting vertically up in the air. Another claims that somehow it can sense interference and switch from one antenna to the other to avoid interference in transmission. How well that works, I have no capability to test it. It's an interesting potential thing to do. There are also a lot of interesting warnings that can pop up when you have a transmission problem. For example, I once heard someone claim there was a problem with transmission because of what the person had in his or her pocket. I thought, that can't happen, can it? Well, I took a beacon, I put it down as a target, and I put several energy gel packets on top of it. Of course, I always have many as a Rondo race guy. Sure enough, the signal was diminished like a range of 5 meters or something. Contacted the company, asked what was up with that. They did some research and they said, yeah, those packets, they have a foil layer in them. So when you go out touring and you have your sandwich, put it in a Ziploc bag, don't put it in aluminum foil. You can really block the signal that way. And getting back to beacon capabilities, the good news is the particular beacon I was practicing with as a target, and that's how the inquiry came to us, it actually did flash a warning for its transmission. So somehow it could sense that its signal was not going out the way it should. And that's because some beacons upon startup, they can somehow sense their own signal and see if something is wrong with the transmission. However, when you're searching, which is where interference is a much bigger issue, you know, I don't think there's any way a beacon can do anything about that. It has to do with that disclaimer that you see if you ever read the user's manual about how it's supposed to accept interference. The good news about that is it's very easy to test that. Some things are very difficult to test with avalanche beacons. Even range tests are much more difficult than you would think. But just go out into the field, take all the devices you normally take out, put them close to your beacon and see what happens. Things like heated gloves, those can really wreak havoc with a beacon search. Headlamps, that can be bad too. And even phones, and this is easy to test also. Even if you're not making a call with your phone or doing something else, just putting a phone up against a searching avalanche beacon can cause all sorts of crazy ghosting. The good part about it though is the range for interference diminishes very rapidly. So if you have your phone in your back pocket and you have your avalanche beacon out here, you're going to be okay, unless it's because you have heated gloves and, well, they're on your hands. So that's something to really be aware of.
Great, thanks. So another question we have from Charles is, beacons have hardware constraints, but one company has an app that includes training routines. Did you see, or do you see room for significant strides in the phone app-based training routine, or is this limited in usefulness?
I'm sorry, could you repeat the first part of that? I was looking at one of the
Sure.
chat.
Yeah, beacons have hardware constraints, but one company has an app that includes a training routine. So do you see room for significant strides in the phone app-based training routine?
I'll admit I have not looked at an app for beacon training. I'd be curious which one it is. I have not looked at it. I'm kind of doubtful that an app is going to help you that much for beacon training. It's one of those things where you really have to go out in the field and practice. There's just no substitute for that. I mean, the good part is, well, you don't need to practice as much as you should. I mean, you should still practice a lot, but you know, years ago when I was teaching avalanche courses and people had analog beacons or really primitive digital ones, it would take someone forever just to learn how to do a simple single burial search. Now when I'm teaching a course, yeah, the initial, you know, finding one beacon, you know, I can have my 10-year-old daughter do that instantly. Multiple burials, that's where it always gets more complicated. How an app can help you, you know, it seems like that's just at the level of, you know, a PowerPoint presentation that we do briefly in an avalanche course, and then we actually have to get outside and search for real.
Right.
Oh, and for the chat person who says I'm using my economist credentials to push the Avalanche, American Avalanche Association merchandise in the background, that's part of it. The other part is before the pandemic and I started using Zoom, I allowed my daughter to turn my home office into her Lego city. So it's blocking the view of the Lego city unless you want to get a better view of that.
Awesome. Another question from Bertram is, if the industry was open to not using 457 frequency, would there be opportunities for bigger improvements? So that is thinking outside of what the technology currently allows.
I think it would have to be. I mean, for instance, several years ago, a patroller and I, we bought some weird little locator device. I tried finding it online, but it doesn't seem to exist anymore. And you could attach it to your car keys, your phone, you know, your young children or whatever, to try to find these things in short range. And it was pretty interesting. It used a frequency that didn't work at all to penetrate snow. We tested that by putting one of the tags behind a water cooler, and the frequency, transmission pretty much disappeared. But, you know, multiple burials, multiple locators, it was easy. Each locator tag had a unique ID, so there was no problem with getting things mixed up. I would think that if the beacon spec allowed a beacon to do more than just go beep, it would be really easy to do that. On the other hand, you know, we're not starting from scratch. We have so many of the old beacons out here. This F2 I happen to have. The reason it was called F2 is because it searched on both frequencies. And that was when the Europeans used one frequency, and SCADI, if I remember that correctly, originally developed out in my home state of New York, Buffalo. Actually, maybe it was a different one. I might be mixing up my names here. They had a different frequency. And so eventually a compromise was reached whereby North America and Europe would use the same frequency. It wasn't much of a compromise. North America had to use the European frequency. And so you had two incompatible frequencies out there. That was a pretty rough transition time when you had beacons like this that tried to do it both. Could there be some sort of way that a secondary frequency could be adopted by all companies and have that additional information? I don't know, but that would certainly be a big breakthrough, and I think it would solve a lot of problems we're currently facing.
Great. Yeah, you answered a couple of questions there that we had, so thanks for that. And then maybe just one more question, because we've reached just about 8 o'clock, and maybe it's a good refresher for all of us, but talk a little bit about lithium versus alkaline batteries in our beacons.
Yeah, so some beacons do allow you to use lithium batteries, so it's not going to fry the mechanism. You have to be very careful about using them, though, in that you want to put in a brand new set of lithium batteries and then keep them in there. Don't keep swapping them out and using them in different devices. Because actually, actually, hold on. I'll get back to the something in the chat that I just noticed there. The reason for that is the nature of the power curve. Alkaline batteries, you know, they start off at, you know, their maximum amount, and then they gradually decline over time until they can't power the device over time anymore. A lithium battery starts off strong and then it stays strong. You know, it's like someone who goes charging out on a powder day braking trail and then suddenly says, you know, I can't go on anymore. I've had it. Time to go back to the trailhead. So a lithium battery will be close to its maximum power until, with almost no notice, it dies on you. So how can a beacon sense with its power meter that a lithium battery still has, say, 50% left? Well, it really can't sense that. Instead, it's calculating it. So it's kind of like if your car gas tank didn't sense how many gallons are left in the tank. Instead, it said, let's see, you've been driving for so long at such and such a speed. Yeah, you know, I think you're at about 50%. So for the beacons that do allow lithium batteries, yeah, use them, but be sure to put in only a new pair and don't take it out and then put it back in. Otherwise, you could be in for a really bad surprise. And then for the person who commented, yeah, the frequency 457 kilohertz, you're never going to have something much different than that because you have to have that long wavelength to penetrate the snow. The issue is, could it do something other than just give that beep for so long and be off for so long with no differentiation among different models of beacons and different units of beacons, beacon models, other than pretty much by happenstance?
Great. Well, thanks, Jonathan. That was a great presentation, and thanks for answering those questions. That brings this evening to a close, and I just want to thank everyone again for joining us tonight. It was three great speakers on a variety of topics, and thanks to you all for joining us. The next one will be January 10th. Look for emails from Dan about the topic and the speakers for that session. And thanks again to everyone. I hope everyone has a great month until we see you next time.